Hello dear friends, welcome to my channel. Today's discussion is classical mechanics. So first we discuss transformation equations. In three dimension, the spherical coordinate arc theta, phi of the positions of a particle is related to the Cartesian coordinates x, y, z as follows, where x is equal to r sine theta cos phi and y is equal to r sine theta sine phi and z equals to r cos theta. Hence, you have to remember these three coordinates transformations because this is very important for physics. R is equal to root over x square plus y square plus z square and theta is equal to tan inverse root over x square plus y square divided by z and phi is equal to tan inverse y by x. We may represent the relationships spherical and Cartesian coordinates as follows. X is equal to r comma theta comma phi and y is equal to r comma theta comma phi and z equals to r comma theta and r equals to r comma theta comma phi. If the time variable is included, then r is equal to r comma theta comma phi comma t. This is the variable. We may represent the coordinates by q1, q2, q3 having the relationships with the Cartesian. So friends, in the transformation of axis, you get x, y, z and p equal to x comma y comma z r sine theta. This is the way the x is equals to r sine theta cos phi. How? Because this is r, this is theta, this is phi, and this portion is r sine theta. This portion is r sine theta, and this is cos phi. Cos phi is equal to this portion. This position is cos phi. Cos phi is this position. I get this position is r cos theta, r sine theta, cos phi, and this position is r sine theta. Y is equal to r sine theta sine phi, and z equals to r cos theta. So friends, I hope that there's this diagram clear total concept. Friends, how is it r cos theta, r sine r, r, r cos theta, z equals to r cos theta, y is equal to r sine theta sine phi, and x is equal to r sine theta cos phi. Very clear diagram. X is equal to x into q1, q2, q3, comma t, and y is equal to q3, q1, q2, q3, comma t, and z is equal to q1, q2, q3, and r equals to q1, q2, q3, comma t. In general, if x1, y1, and z1 are the Cartesian coordinates of the ith particle, then its position vector Ri is the given Ri equal to q1, q2, q3, qn, t, which gives the transformation equation degree of freedom. Now we discuss degree of freedom. The minimum number of independent variables or coordinates required to specify the position of the dynamical system and consisting of one or more particles is called the number of degree of freedom of the system. So what is degree of the freedom? The minimum number of independent variables or coordinate required to specify the position of a dynamical system and consisting of one or more particles is called the number of degree of the system. The motion of a particle moving freely in space freely in space can be described by a set of three coordinate x, y, z, and hence the number of degree of freedom possessed by the particle is 3. A system of two particles moving freely in space requires two sets of three coordinates, six coordinates to specify its position. Thus, the system has 6 degrees of freedom. If a system consists of n particles moving freely in space, we need 3n independent coordinates to describe its position. Hence, the number of degrees of freedom of the system is 3, and the configurations of the system of n particles moving freely in space may be represented by the position of a single point in 3n dimensional space, and which is called configuration space of the space. The configuration space for a system of one freely moving particle is 3 dimension, and for a system two freely moving particles is 6 dimensional. In the latter case, the configurations of the system of the two particles can be represented by the position of the single point with 6 coordinates in 6 dimensional space. The system has 6 degrees of freedom. Its configuration space is 6 dimensional. The number of coordinates need to specify a dynamical system becomes smaller when the constraints are present in the system. Hence, the degree of freedom of the dynamical system is defined as the minimum number of independent coordinates required to specify the system compatible with the constraints. Limitation imposed on the motion of a particle or a system of particles is called constraints. Constraints limit the motion of a system. Therefore, the number of independent coordinates needed to describe motions is reduced. For example, if a particle moves on a circle, then only one coordinate qi equals to theta is sufficient to describe the motion, and because the radius a of the circle remains the same, hence the degree of freedom of the system 1, and if the r is the position vector of the particle at angle theta relative to center of circle, then mod of r equals to a, or otherwise r equals to a. So what is constraint? Limitation imposed, must remember, imposed on the motion of a particle or system of particle is called constraints. Equation 1 expresses constraint for a particle in circular motion, which is called holonomic constraint. Similarly, in case a particle moving on the surface sphere, two independent coordinate q1 comma theta and q2 equals to phi are required to describe the motion. Since radius a is constant, hence the degree of freedom of the system is 2. Let the constraints are present in the system of n particles. The holonomic constraints equations from of constraints is f r1 r2 r t equals to 0. Let there be a n number of such equations to describe the constraint in the n particle system. Then by using equation 2 we may eliminate 3n coordinates, thereby 3n equals to m independent coordinates with 3n m degree of freedom of the system. Let 3n minus m is equal to n, then the degrees of freedom of the system in n. Thus, we have n independent variables q1, q2, qn in terms of which coordinates r1, r2, r3, rn can be expressed as r1, r2, rn in here. Generalized coordinates. The name generalized coordinates is given to a set of independent coordinates sufficient in number to describe completely the state of configurations of dynamical system in equation 3. q1, q2, q3 are generalized coordinate. The generalized coordinates of the junction of n variables r1, r2, r3, rn one time variable t are given by qi is equal to r1, r2, r3, rn, t, where I is equal to 1, 2, 3, k, where qk is equal to qk is the coordinates of a point in k minus dimensional space, which may represent the configuration space of the system. Here q1, q2, qn are independent of each other, non-holonomic constraints. Now we will discuss non-holonomic constraints, the constraints which are neither expressible in the form of equation 1 and equation 2. This is the equation 2, equation 1, this is equation 1 this way, and this is the equation 2 this way. I cannot express are called non-holonomic constraints. Example, the motion of particle plays the surface of a sphere of the radius described by mod of r greater than equals to a by mod of r minus a less than equals to 0. The particle will first slide down the surface and then fall off. Constraint for the motion of molecule contained in spherical shape container is mod of r less than equals to a or r less than equals to a. In a non-holonomic system, all the coordinates cannot vary independently. Hence, the number of degree of freedom of the system is less than the minimum number of coordinates needed to specify the configurations of the system. Constraints are further described as rehonomous and scleronomous. And in the former, the equation of constraint contain the as an explicit variable, while in the latter they are not explicitly dependent on time. And constraints may also be classified as conservative and dissipative. In case of conservative constraints, total energy of the system is conserved during the constraint motion and the constraint force do not do any work. In dissipative constraints, the constraint forces do work and the total mechanical energy is not conserved. Time-dependent or rehonomic constraints are generally dissipative. So rehonomic is time-dependent. Rehonomic is time-dependent and time-independent, I think, scleronomous. Now Lagrange's equations. Consider a system of n particles. The transformation equations for the position vectors of the particles are Ri equivalent to q1, q2, qn, I equals to 1 to n, where t is the time and qk is equal to k equals to 1, 2, 3 up to n are the generalized coordinates, and differentiating equation 1 with respect to this dr by dt partial derivative del r by del ri del qi t del ri del q2 del q2 del t plus dot up to del ri del qn del q2 del t plus del ri del t, and vi is equal to ri dot and del ri divided by del t. Vi is equal to ri dot. This is the 2, and where qk are the generalized velocity, the virtual displacement do not depend on time. Actual, according to the D'Alembert principle, summation of I equals to n to fi pi dot del ri is equal to 0. This is the D'Alembert principle. And D'Alembert principle, so here summation I equals to capital N fi del ri equals to, this way I can express del ri can be expressed del ri del q del qk, and this is the product of the two summations del fi into del ri del qk, and this can be written gk del qk, k equals to 1 to n, where gk is equal to I equals to capital N fi and del ri del qk are called the component of generalized force associated with the generalized coordinate qk, and I equals to 1 pi dot and del I equals to, this way I can retain, it can be written this way it can be written, and where T is equal to summation half mv square vi square is kinetic energy of the system. Must remember this formula is very important. Summation k equals to 1 to n d dt del t by del qk minus del t divided by del q dot k. Using equation 5 and 6, equation 4, we get, this is the equation we get the dt of del t 5 and 6. These equations we get, and from these equations we get this equation. This is the equation del qk, and as the constant are holonomic, so this portion equals to 0 and this portion equals to gk, and this represents the general form of the Lagrange equations of holonomic dynamical, a scalar potential, and gk is equal to del b minus del b by del qk. Thus equation 8 becomes del dt of del t by del q dot k and del t divided by del q dot k is equal to minus del v by del qk, and after that we can get this equation, and the scalar compositional position v is generalized coordinate qk only not depending on generalized velocities. We can write equation x as this way. We define a new function given by L is equal to t minus v, which is the Lagrangian of the system, and thus equation 11 changes to this way, and this equation is called Lagrange's equation of conservative system. Now we will solve some example based on Lagrangian equation. A bead slides on a smooth rod which is rotating about one end in a vertical plane with uniform angular velocity omega. Find the equation of motion. So friends, solution. This is rod, and this is a beads slides on. Let m be the mass of bead at time position. position of the time of the beat is r comma theta on xy xy plane. So total kinetic energy, total kinetic energy to T equals to half mv square plus half m, sorry, not m, in here inertial momentum. So I omega square. So I can write this way: half m r dot square minus half m r theta dot square. And potential energy V is equal to mg r sin theta. And L equals to T minus V. So T equals to half m r dot square plus half m r square theta dot square minus mgr sin theta. By using Lagrange's equation, we will go to in here. What is my Lagrangian equation? Del L by del R minus ddt into del L by del R dot equals to 0. So del L by del R equals to m r r theta dot square minus mg sin theta minus m r double dot equals to 0. So which is the means the required motion. Theta dot is equal to omega. So we get m r omega square is equal to g sin theta theta is equal to, we can say, omega t, omega t plus r double dot. So our question is, find the equation of motion. So my motion equation of motion is this. This is my equation of motion, r omega square g sin omega t minus plus r double dot. Now we will go to solve another problem. Pendulum. Obtain the equation of motion of a simple pendulum by using Lagrange's method. Hence, deduce the formula for each time period for small amplitude. So friends, this is my pendulum. I point is A, and this way is moved, and this is O, and this point is A to B. This okay. 1 minute. Simple, that if we will write this way, this is C, this is O, and this is theta, and this is B, and let the mass is M, and S is the path of curvature. So let theta and theta be the angular displacement. Theta is angular displacement, theta is angular displacement, effective length. L equals to, L is effective S equals to L theta, and T is equal to half m v square, theta dot square, half m v square is equal to V is equal to L theta dot. So potential energy of the system, potential energy is equal to V equals to mg ob, and mg ob means mg into oc minus bc, mg into oc minus bc, and mg oc means L minus del L by del theta equals to okay, L equals to, now L equals to T minus V, and T equals to half m L square into theta dot square minus mg into L minus, I have to create actually L. After that I can get del L by del theta. So L into L minus cos theta is equal to mgl sin theta plus mgl sin theta. Now del L by del theta dot equals to ml square theta dot. So apply Euler-Lagrangian equation del L by del theta is equal to ddt of del L by del theta dot equals to 0. So the value is the equation of this equation, we get m L square theta double dot plus mg L sin theta gl sin theta equals to 0. The present the equation is simple pendulum sin theta equals to theta. So theta double dot plus g by L, this is my equation. So and this is my equation of the simple pendulum. The theta double dot gl by theta equals to 0. This is my equation. So this equation is theta double dot plus gl by theta equals to 0. So this is my equation. Use Lagrange equation of motion. Motion to find the equation of a compound pendulum in a vertical plane above a fixed horizontal axis. Hence, find the period of small amplitude oscillations of the compound pendulum. So this type of questions is coming from MSc Maths and also BSc Maths. Kinematics. This is very important for kinematics. Write this way. This is my SBCO. This angle is theta. Let the compound pendulum be suspended from S with C as center of mass. It is oscillating in the vertical plane, which is the plane of paper. Moment of inertia of a pendulum about the axis of rotation, so S, is given I equals to IC, theory of parallel axis. This is the formula of theory of parallel axis. M L square, and it can be written M K square plus L square, where M is the mass of the pendulum. So IC is equal to M K square. Radius K equals to radius of gyration. Theta equals to instantaneous angle. T equals to half L theta dot square mk square plus L square. Potential energy V equals to minus mg L cos theta. This effective length is L, and Lagrangian L equals to T minus v. So L can be represented. At first I have to write what is the value of L. L is equal to, can be written, half m square plus L square plus mgl cos theta is equal to minus mgl sin theta. Del L by del theta dot equals to theta double dot, sorry, theta dot, del L by del theta dot is equal to m k square plus L square theta dot. This is my total equation. Now I have to find out Euler equation, Euler-Lagrange's equation. Del L by del theta minus ddt into del L by del theta dot equals to k square plus L square theta dot minus theta double dot, because in here del L by del theta ddt, plus minus minus plus mg L sin theta equals to 0. It is multiplied by half, sorry, it is multiplied no, it is not half, it is this way, equals to 0. So we can write the value is theta double dot plus g L k square plus L square sin theta equals to 0. And in case of theta, as theta is very small, so sin theta equals to theta. So friends, we get the equation theta double dot plus gl plus k square L square theta equals to 0. E equals to 2 pi root over k square plus L square divided by Lg equals to 2 pi root over k square by L square plus 1 divided by g. It is not L square, it is L. A mass is suspended at the end of a light spring having spring constant stand equals to k and is set into vertical motion. Use Lagrange's equation to find the equation of motion of the mass. So friends, anytime t, let the displacement of m from the equilibrium position O bx is t equals to half dx by dt whole square, half m x dot whole square. The work done during its fall 0 to p from O to p is w 0 to x mg minus kx dx mgx minus half kx square. Lagrange's equation to del L by del x minus ddt into del L equals to 0. Now L is equal to T minus V for potential, and work done V equals to minus W. So it is half A x square minus mg x. So we get del L by del x is equal to, so whatever we get half k x dot whole square mgx minus half mg plus kx minus ddt divided by mx equals to 0, x dotted whole square. So this value we get m into d square x divided by d t square is equal to mg minus kx. This is the Lagrange's equation of the motion. That is non-holonomic systems are given by A and divided by del L by m unknowns in n coordinate and qk order of differential, which is the equation of the constraints. Hamiltonian principle. Hamiltonian principle states that the time integral of the difference between the kinetic and potential energies of a dynamical system is S is equal to T1 T2 T minus V dt, and hence the stationary extremum value of actual path of motion S is equal to T1 T2 L dt has stationary value L is equal to T minus V. The quantity H is called Hamilton's variational principal function. Since S is stationary, del S equals to 0. And some important formula. H is equal to summation k q dot k minus L. And del L by del q dot k is equal to Pk. And H is equal to formula must remember, friends. Del H by del T, del H by del qk is equal to minus P dot k. Del H divided by del Q is equal to Q dot k. So del H, this equation are very important for a learner, that del H by del T is equal to minus del L by del T, and del H by del Q is equal to minus P dot, and del H by P is equal to Q dot. This formula is very important, friends. And now we will discuss principle of least actions. According to the principle of least square action for a conservative system, del into T1 T2 summation k pkq dot k dt equals to 0 is called action and also known as Hamiltonian characteristic function. Principle of least square action is del W equals to 0, del W plus del T plus dW by dt equals to 0. Now we describe the Hamiltonians and Hamilton's equations of ideal spring. Hence we know that L equals half m x dot whole square minus half k x dot whole square, half k x square, where k force constant of the del L by del x dot, because friends by the canonical we get del L ex or equals to m x dot or x dot is equal to pk minus L, px x dot minus half m x dot whole square minus half k x square. What we get? The Hamiltonian H equals square x divided by 2m k x square. X dot equals del h divided by del px divided by px divided by m, and p dot x equals minus del h by p dot x. P dot x is equal to minus del h by del x through the canonical form. Del h by del q is equal to minus p dot, and del h by del x here q is equal to x, here q is equal to x, so p del h by x equals to minus k. Thus the equation of x double dot plus, so the equation is mx double dot plus kx equals to 0. So x double dot plus k by m x equals to 0. So friends, write Hamilton's equation of motion show that the Hamiltonian is a damped harmonic by del p according to the p dot is equal to minus del h by dot is equal to del h by del p and is equal to del h by del x. How can I get it, friends? By canonical. So whatever I get, I write in here h equals to p square by e to the power minus rt plus half m x square e to the power p. So if I will get del h by del p, so whatever I get, friends, I get x e to the power r. P is equal to p dot is equal to m x double dot rt m r. Substitute for p dot in equation 1 x dot plus write Hamiltonian equations of motion for a particle moving in the xy plane under the influence of a central force with inverse square law. Question number 7. T equals to half m r dot square plus r square theta dot square. A is equal to t minus v. In here, q1 equals to q1 means coordinate equals to r, and q2 equals to theta. Q1 generalized momentum r del L del q1 p r del r dot is equal to m r dot, and p2 equals to del L divided by del equal to del L by del theta dot equal theta dot. Therefore, r dot is equal to p r by m, and theta dot equals to p theta m r square, which is equal to t plus v, and p equals to half m p square r divided by p square theta divided by m square by r to the power 4 into m, or k equals to del h by p1 equals to q dot and del h by del p and pr by m r dot and p square theta. Now del h by del equals to minus p1 dot del h by del r minus p1 dot theta r is equal to minus p dot r, that implies theta divided by m minus del v by del r equals to m r double dash. Similarly, for k equals to, or k equals to 2 del h by del p to q2 dot and del q2 minus, so del p theta dot theta is equal to minus p dot theta. Now p theta r square is equal to theta dot and minus p dot theta, that implies equal to m r square theta dot, that implies p theta equals to constant. So our equation is m r square theta dot constant. Now the question is from, now p dq minus capital P d capital Q minus p dq is equal to sine p is equal to 0. Not 0 is equal to canonical form. I have to find out. So this value is sine p cos p, if we multiply capital P with dq, then we get cos p dq minus 2q sine p dp minus small p into dq. This differentiations is very important. Okay, these differentiations, how can I differentiate? ddx duv is equal to du into v plus dv into u minus 2q sine square p dp. So friends, we can write this equation del divided by del q half into q into sine dq plus del p half into q sine 2p minus pq into dp. We can write this way, and this equation can be written as del f by del q into dq plus del f by del p into dp, so that we can write this is as df equals to half q sine 2p minus pq. So this equation is C and this equation equals to A. Next problem, given the Lagrangian L is equal to half into mu r dot mm divided by r, where mu is equal to mm plus capital small m. Then the general equation of the Rautian. So the now start to write solution. The is r equals to summation k equals to 1 to s pk q dot k minus l. This is the Rautian equation. Since theta is the cyclic coordinate, so r equals to theta dot minus Lagrange's is equal to Lagrange's equation. This is my Lagrange's equation. I just put in here. I am putting in here half mu r dot square plus r square into theta minus g capital M small m divided by small r, and p theta equals to del L by theta. This is the canonical equation, mu r square theta dot equals to constant. Theta dot is equal to p theta by mu r square, and therefore capital K, sorry, capital K, not capital R, is equal to half mu r dot square minus, not sorry, minus plus p theta divided by 2 mu r square minus capital G small m divided by r. So my answer is equation, the general equation of Rautian. This is correct. And in here Rautian equals to minus. So I think that this is correct if it is minus. So others, this is also wrong. Is wrong. Rautian is equal to del L by del theta, del L by del p theta. So this is correct. E Lagrangian. Wrong in here. Minus. Now next problem is based on canonical form, capital P to Q cot P and capital Q equals to what is given, log of 1 by P sin P. The transformation is canonical, so del Q divided by del Q into dq plus del Q divided by del P into dp, and it can be written this way. How can I find out del dq? That is this way. Del Q del by del Q log of 1 by P sin P into dq, and del Q del of log del by del P into log 1 by P into dp. Can be written this way: 1 by P sin P divided by sin P by, okay, sorry, I have written wrong. It is Q, it is not P. It is not P. It is, I have written wrong. Q is equal to 1 by Q log sin P. I have written wrong in here. It is Q. So 1 by Q sin P into sin P Q square dq plus 1 by Q sin P divided by cos P divided by Q dp, and minus dq divided by Q plus cot P dp. This is my answer. So now therefore capital P dq plus small p dq equals to, it is not plus, it is minus, capital P canonical form minus p dq q cot P minus dq by q plus cot P cot p into dp cot p dp minus small p dq can be written del q into qp plus q cot p into dq plus del p qp plus q cot p into dp equals to del f by del q into dq plus del f by del p into dp. So my f is equals to generating function. So exact difference f is equal to qp plus q cot p. So my answer is 47 because this transformation is canonical. This is correct. The generating function is very simple because we get already that f is equal to qp is equal to q cot p, but now so capital Q is equal to we get log of 1 by q sine p, and we can write this is this value sine p is equal to e to the power capital Q into small q, and cos p is equal to 1 minus q square e to the power 2q whole to the power half, because cos p is equal to root over 1 minus sine square p. So this cot p equals to, so cot p equals to 1 minus e to the power 2q half divided by e to the power q into q. Now we can write this equation in f equals to qp plus q cot p, and after that we get e to the power q and in here another factor p is equal to sine inverse e to the power q into small q get q into sine inverse q into e to the power capital Q plus e to the power minus q into 1 minus q square e to the power 2q minus, sorry, not minus, plus half. So the required, this is required generating function. So friends, we get our answer is correct. Next, we will go to solve the given the transformation q is equal to log 1 by q sine p, p is equal to 1 by, given the transformation q is equal to log 1 by q sine p, p is equal to q cot p, thus this transformation is canonical, this transformation is not canonical, q dot is equal to del h by del p. I have r q dot is equal to del h by del p, p dot is equal to minus del h by del q divided by p and qp dot cos p minus q dot into sine p. Just the derivatives, these portions q dot is equal to, I just derivative with respect to t, del q by del t. Okay, I hope I can clear. Q p dot cos p minus q dot sine p divided by q sine p is equal to minus cot p into del h by del p. Del h by del q, because p dot is equal to del h by minus 1 by q into del h by del p, because p dot is equal to del h by del q. It can be written very more simplified. Q q cut, this portion and this portion cut. So what we get q p dot cot p and p dot is equal to minus del h by del q. Okay, and this q is cut, so this portion will cut. After simplifications, this q is also cut, so it can be written in here q. So it is p dot cot p minus q dot by q sin p cut. So q dot by q dot value is del h by del p and p dot value is del h by del q, canonical form. Video how to generalize canonical form. So this as this way minus cot p del h by del p into del p capital del q minus 1 by q del h by capital del p into del p and del p by del p and del q by del p minus cot square del h by del p and del p by del that is the value will become plus q into cos divided by q into del h by del p del capital P divided by del small p value I this capital P value that what is my P value? P value is equal to q cot P q minus cosec square P del P is equal to q cosec square by P. So I get this value is cosec square P minus cot square P is equal to del H by del capital P can be written this way del H by del capital P. Now we have to find out P dot capital P dot equal to Q dot cot P minus QP dot P dot cosec square P can be written del H by del P cot P minus cosec square P and Q P dot is equal to del H by del Q by the canonical form we know that P dot is equal to del H by del Q and Q dot equals to del H by del H by del P small p. So it can be written this way cot P into del H by del capital P, del capital Q, it is very this way, and del Q by del P small p, and Q canonical transformation given P plus capital P equals to Q into cot P and capital Q equal to log 1 by Q sin P. Then the generating function del H by del Q divided by del P. It is not del P, it is after that way cot square P del H by del Q minus cosec square P into del H by del Q, and after that we get del H by del Q. So friends, in here you have to remember that del H by del P. What is the value of Q is equal to, what is the value of Q? Q is equal to log 1 by Q sin P. So friends, you know that how can I get this del Q by del Q by del P, this value I have already get from in here. In here you see that I in not this equation, but this equation in here I get what is the value of del Q by Q. This value I have already get. So that I put in del P by del Q. So I use this result in here. Get in here minus del H by del Q. So our problem is Q dot is equal to minus del H by del P and P plus del H by del Q. Hence, the problem is canonical. The transformation is canonical and Q dot is equal to this option is right, this option is right, and this option is right. Now, we will try to solve next problem number 12. H equals to Q2 minus A Q1 square plus B Q2 square. Q dot is equal to del H by del Pi Q dot I, and P dot I equals to minus del H by del Q I. Q dot is equal to minus and P1 dot equals to minus P1 minus 2A Q1 and P2 dot equals to minus equals to P2 minus 2B Q2. So dq1 divided by q1 equals to dt, and log q1 equals to p plus c1, and q1 is equal to e to the power minus t e to the power plus t plus c1, and q2 is equal to power minus t plus c2, and c1 and dq1 by dt plus p equals to minus 2b e to the power p plus c2 by just putting the value of q2 equal to this equation. This equation p2 equal to p2 dash dot is equal to 2b minus q2. After integrating the problem, we get p2 is equal to dp1 equal to p1 to a e to the power, it is a not b, c1, and dp2 divided by dt plus, sorry, not plus, this is p2 is equal to minus 2b e to the power t plus c2. So p2 is equal to minus 2b t e to the power t plus c2 plus e to the power t plus c3. Similarly, in here we get, and this position, this answer is p1 equals to 2a e to the power t plus e to the power t plus c1 plus e to the power c2 minus t. So this is my p1 and p2 value. How can I get? I get by if through integrating factor if, linear equations. Integrating factor is equal to e to the power dt, that is e to the power t. In one case, another case e to the power minus t. In here, if is equal to e to the power minus dt equal to e to the power minus. So my both answer, which is correct, this answer, this d, c, d, both are correct. Was bracket, Poisson bracket, qi comma qj and p comma q is equal to summation k. So friends, the problem is canonical, canonical, canonical Poisson bracket. So friends, according to the Poisson bracket, this problem I into del q del pk divided by del q j minus del q k divided by del q j, del pk divided by del q qj, del q I, where p and hence del pk divided by del qj equals to 0 equals to del pk divided by del qi. Therefore qi comma qj equals to 0. Next problem, friends. Next is this option is correct. Next option is qi pj 1 if I equals to j, 0 if I does not equal to qi comma pj q comma p equals to summation k del q k divided by del q I del pj divided by del pk divided by del pj minus del qk divided by del pi del pk divided by del qj. Okay, del pj del qi it can be written this way. Now p and q are independent. P and q are independent. So del qk divided by del pj and del pk. So friends, this portion is 0, so summation k del qk divided by del qi and del pk divided by del pj. It can be written summation del kj into del ki equals to del ij, and summation pj equals 1 0 I equals to j and I does not equals to j. So friends, our option is first and second is correct, and these options is. Now we are going to q dot k into qk minus root over 1 minus q dot square k equal to q dot k equals to qk minus half into root over minus q dot k whole square to the power minus half into 2q dot k, and this minus minus plus. So I can write this way: del L divided by del q dot k equals to qk plus half. These two and these two will cut. I can write this way that q dot k divided by root over 1 minus q dot square k. So apply the Lagrangian equation del L divided by del qk minus ddt into del L del Q dot K equals to 0. So friends, we get Q dot K ddt equals to 0. So we need to calculation. So whatever that after calculating Q dot K Q double dot Q dot K minus Q double dot K minus Q dot K. This is Q dot K and this Q dot K and this Q dot K is cut. So I get Q double dot K 1 minus Q dot whole square K to the power half 1 minus Q dot whole square K whole to the power half minus 2 Q dot K divided by 1 minus Q dot K whole square equals to 0. Means ddx of Q by V. This formula is V square into V into du by dx minus u into dv by dx. After calculation Q double dot K, because as the time is very large, please calculate this and get this value. Very simple calculation spreads. Now we have to solve. Given the transformation, this is our last problem friends. Given the transformation defined q is equal to 2 mod of 2 p sine q and p is equal to mod of 2p cos q, then so whatever we get, so friends, q square is equal to mod of 2p sine q and p square is equal to mod of 2p is equal to cos q. So tan q is equal to q square by p square. So friends, here is some written wrong. This square root is not over the cos q. So I hope this is the root over 2q. So this wise we in here q by p and 2p 2 capital P is equal to q square plus p square. Question is wrong. I just corrected this question. So capital P is equal to half into q square plus p square. Now get by bracket condition capital Q comma Q equals to capital P comma P equals to 0 and capital Q comma P equals to 1. Question bracket condition is the transformation canonical is the transformation is canonical. So this is our value equation 1, I write this is my equation 1 and this is my equation 2. From equation 1 we have sec squared q is equal to 1 by p, and del p by del q is equal to q. Sec squared q del q is equal to minus q divided by p square, and del p by del p is equal to p. We have to see that q comma p del q comma del q into del p comma into del p, and del q into divided by del p small p into del p divided by del q equal to 1 by p cos square capital into p plus q by p square q, that is cos square q equals to 1, because this portion is sec square q. Hence the transformation is canonical. Thanks for watching.